So we're going to start with this because this really puts this printer in perspective. This is a 120 millimeter bed like you would find on a Voron V0 or a Rook, for example. And that's compared to a Prusa Mark IV bed, standard printer size bed you've probably seen. This is a Prusa XL bed, 360 millimeters. And this is the bed on a Venture XL. That's 600 by 600. So yeah, really puts it in perspective. So yeah, this is the Fysetc Venture XL. It's a kit 3D printer. And first things first, it's big. It is a 600 by 600 by 600, little asterisk there, 3D printer. It is big, and it was a fun build. If you want to see how the build itself went for this 3D printer, I live streamed the whole thing on this channel, so you can check out the playlist below. Make sure you subscribe so you don't miss out live streams in the future. But yeah, it's not a bad build, and we're going to talk about this now. I'm hesitant to call this a review of this 3D printer. I do have about 200 plus hours of print time on it, but as you can see from the fact that the panels aren't on it, and there's still some final stuff to adjust and tweak. I'm not calling it a review, so consider this an initial impression of the Fysetc Venture XL. So let's get started. So first things first, let's talk about the elephant in the room. This looks a lot like a Voron Phoenix. If you looked at this and then you looked at a Voron Phoenix, you'd probably assume they are quite similar. Maybe is this Fysetc's version of the Voron Phoenix? I would not fault you for jumping to that conclusion. This is basically a Voron 2.4. The gantry is essentially, other than the fact that it comes with CNC parts, and that's one cool thing with this kit, all the motion system parts for this printer are CNC'd aluminum. There are obviously 3D printed parts in the tool head and some like brackets and mounts and whatnot, but the motion system is CNC, and the motion system is essentially Voron 2.4. We have 2020 extrusions, we have MGN 12 rail for the X, MGN 9 for the Y, we have our AB motor mounts in the back. As you can see, the motors are slightly different. The motor is on the top instead of the bottom. That's because this gets a little bit lower down to the bottom of the frame compared to a stock Voron V2, so this needs to be up top to clear. And these are NEMA 17s. They're bigger NEMA 17s, but they are NEMA 17s. So this is essentially a modified Voron V2.4 gantry. Now the frame obviously is a bit beefier. It is essentially 40/40 extrusions. Now there is a little bit of a cheat here. These curved extrusions here are kind of like L-shaped 40/40, so they're not true 40/40, and then you add in a 20/20 inside to make it a 40/40. It works. And then for the Z motors are mounted up top here, and they are geared to heck and back. They are 27:1 gearing for these motors. Again, NEMA 17s, and the idlers are on the bottom. And so it is essentially, if someone took a Voron 2.4, mixed it with a little bit of Doom Cube, sprinkled in some CNC parts, and then made it a little bit beefier, you get the Venture XL. The beds count 4. That's right. There's 4 beds on this printer. One big spring steel flex plate, but underneath you'll find 4 beds. These are 4 300 millimeters, essentially normal Voron spec beds. The electronics, thankfully, on the side. We do have an electronics box on the side. Really nice from Fysetc, the fact that it comes mostly pre-wired up. Everything that comes within the box is already pre-wired up. You just have to wire up everything you add to it. So wiring from the tool head and the motors and the beds themselves. But the electronics enclosure is already pre-set up and it mounts on the side. In fact, you really only have to flip this printer once during the assembly and nothing after. So it's really nice that way. For the electronics as well, we are running 24 and 48 volt power supplies. The AB motors are running at 48 volts. We also have a nice large touchscreen up front here. The actual brains running clipper is in this screen as well. Their Raspberry Pi equivalent is there. Up top here, we do have a webcam. It's a Logitech C270, I believe. And that is basically a quick rundown of the specs of the printer. Now, how did the build go? Not too bad. There's always room for improvement. Pobity's Nerfic and Fysetc is not Nerfic. There was some deficiencies in the manual itself. I was following the monolithic PDF download manual off of their GitHub. Apparently there's a wiki now with some more updated build instructions, more up-to-date stuff. They did take some feedback from my build to improve the manual as well. So I'd be following the wiki and the newer up-to-date manual if you are building this. But when it comes to the build, other than some quirks of calling out the wrong screw size, calling out button heads when they should be flathead screws, some of the diagrams could definitely be a lot more detailed. For example, the AB motor mounts, those assemblies are basically just one big exploded diagram. It's very easy to accidentally install something in the wrong way or miss a shim or a washer or something like that. Also, they call out shims at points when there should be washers and vice versa. So I wouldn't really recommend this as a printer. For those that are looking to get their first 3D printer. This is definitely a big undertaking if you're looking to build your first 3D printer. But if you've built a Voron before, if you've built a 3D printer before, you really shouldn't have too much trouble figuring this out. It's not rocket appliances. It's essentially a big beefy Voron V2 with CNC parts. So now that we got the kit built and I've got about 200 hours of printing on it, what are my initial thoughts on the actual physical printer itself? I will say, pretty good. These are a pretty decent set of bones. The CNC parts that come with this kit are very well machined. They're all nice and anodized, very clean. Most of the hardware is good. I haven't noticed any issues with the motors, with the bearings. The screws were pretty good. Some of the T-nuts were kind of with the little spring detent balls falling out, but they're cheap T-nuts and I had tons of extra. If you do run out, just buy some, keep them in stock. You'll probably need them eventually. Some of the downsides with the hardware though, the 3D printed parts, big downside. They are PETG, or at least the kit I got came with PETG parts. That's a no-no for a Voron. So the plan was originally, since I plan on running this without an enclosure for a bit, I always run my new printers when I build them without an enclosure. It's easier to fix stuff when it's not all paneled up. They were handling the temps in my garage just fine and printing just fine, but I did notice I was getting some creep issues on those PETG parts. Some of the screws that were tight were no longer tight, stuff like that. So I've gone ahead and reprinted this entire tool head in ASA from Polymaker, and also I'm testing out all the black parts on it are PPS CF10 from Polymaker as well. So I'm trying out those filaments on this tool head. So far so good, and you'll notice it looks a little bit different than the stock tool head. The stock hot end that comes with this printer, it's like putting a 4-banger in a Ferrari. It was woefully undersized. It's the Sailfish hot end, I believe it's called the Sailfish hot end. Looks okay. It's got a 48 watt heater, 24 volts. It came with a 0.4 nozzle, and at the stock Voron speeds, it handled fine. It printed fine. The problem was a 0.4 nozzle on a large printer like this is a little on the small side. So one of the first things I did was upgrade it to a 0.8 CHT nozzle. And a fun fact about 3D printing hot ends, pretty much all of them are liquid cooled. Liquid plastic it acts like a coolant. When you run plastic through your hot end, it sucks heat out of the hot end itself. So what happens is when you're running that much plastic through a hot end that can't keep up, it can't keep up. With the heater pegged to the firewall at 100% with the 0.8 CHT nozzle, I was barely able to get 15 millimeters cubed a second of flow. That's not good. That's not good. So normally when I review a printer kit, I like to keep it stock as long as possible, or at least until I do a review on it. With this one, I jumped ahead. This now has a Rapido ultra high flow hot end from Fysetc in it with a 0.8 CHT. I wish I could find where I put my Bondtech CHT nozzles at, but this is running the 0.8 CHT that came with the kit. It does come with extra nozzles. It's a generic no-name brand CHT. It is a little on the stringy side, I've been noticing, but functionally it's working fine. And we're getting, I just have the slicer capped out at 45 millimeters cubed a second flow rate, just so I have some margin on top to play with in the future. And it's handling those speeds just fine. Other things that could use a little bit of work, but was really nice, the fact that this came pre-installed with Clipper. Like, obviously this is a Clipper machine, but all the electronics were already pre-flashed and the config was already pre-installed. Essentially, if you wire this thing up properly and you turn it on for the first time, it'll just boot up and you're ready to go. Go do initial testing, pre-flight checks after that, homing, PIDs, whatnot. I did run into an issue during my build where I had some stuff wired up incorrectly because I was following an outdated manual and I had a short somewhere where there's LEDs in the tool head. I ripped out that whole LED harness. There's a short in there. Did I do it? Did Fysetc do it? Did I just pin it out wrong? I don't know. I just removed the whole harness. Can't have a problem if there's nothing there to cause a problem. So after I fixed that, it booted up fine and it's running Clipper, but it's running However Fysetc set it up, there's some weird stuff in there. For example, this is running CAMP, Clipper Adaptive Mesh and Purge, which is a great system. The thing is, CAMP is just part of Clipper now. You don't need CAMP, but this is set up to use CAMP, but it's running the newer version of Clipper, I think. So it's one of those, like, why is it set up that way? I'm not going to mess with it because it's working. And there's a lot of macros and config sections that reference other config sections. So I really don't want to start messing about with stuff that's working, if that makes sense. Another thing, the 4 beds, in my opinion, they should be running sequentially, which means when you tell the beds heat up, you should heat up one bed, then another bed, and just cycle between them until they get up to temperature. That way you're not hitting it with essentially 4 printers heating up their bed at the exact same time, which that's how it ships with. When you heat these beds up for the first time, if you're haven't messed with their config, when you tell the bed to heat up, all 4 beds kick on at once. Luckily, I have it plugged into a 20 amp circuit in my garage. It's designed to plug into a 20 amp circuit, by the way, so you do need a 20 amp plug for this printer, unless you rewire it. But on paper, this should be able to run at 15 amps on a normal 15 amp circuit. The Voron Phoenix does, and the Voron Phoenix uses the same kind of bed setup. So I'll probably end up just stealing the macros from the Voron Phoenix, swapping that over so that we have sequential bed heating, so we're not drawing as many amps as quickly as possible off my circuit inside the house. And another thing, this is a 600 millimeter cube printer. I can't print 600 millimeters cubed. I can do 600 on the X and Y. In fact, there's a little bit of extra room. There's a little bit of extra room with this printer. You probably could easily modify this to IDEX if you knew what you were doing. There's a little bit more over travel. The frame probably could have been a little bit smaller and kept the same print volume. But on the Z, because I've gone ahead and put a Rapido Ultra High Flow in here, my hot end is a little bit longer. So my tool head sits a little bit higher up. And now at Max Z, my XY joint actually collides with this rear right Z motor mount. So what ended up happening was originally it just barely squeaked in at 600 millimeters. It was rubbing, but you could do 600 millimeters of Z. The problem was if you finish a print and your machine goes to its park position, a lot of print end scripts after a certain amount of time, your motors will power off. So you come out, print's done, you take the print off the bed, you hit home. Well, on a printer like this, usually it moves away from the bed before it homes XY. So if you get up close near the top, even if you don't max it out, and then the motors turn off for some reason, whatever reason, and then you re-engage them by doing a home, it's going to move up again, and then it'll crash. With the actual extra Z of the Rapido Ultra High Flow, I'm only getting about 580 millimeters of Z, plus or minus 5 mil, it depends. Now, you could easily fix this by just not using the drag chains. If you go umbilical, you don't have this XY joint here, you don't have to worry about it. That's the joy of a machine like this that's more open. You can tweak and mod and adjust this to your heart's content. The tool head, for example, comes with an end stop. There's an end stop in the tool head as part of the files, and I reprinted the files that came with the kit. And there's an end stop in there. It also has a filament cutter. I don't have it installed right now, but it's essentially the Filamatrix filament cutter. So if you want to put something like a box turtle on here, or an enraged rabbit carrot feeder, you can just add it. You don't have to do any modifications really, other than software. Just adding the macros and adding the configuration for adding a box turtle. In fact, I will be adding a box turtle kit to this printer in the near future because as much as it, multi-material prints this big sound fun, I don't really do a lot of multi-material, but I do want it for filament rollover because I do not want to be babysitting 1 kilogram spools all day. In this current setup, this thing sucks down 1 kilogram spools in about 12 hours or less. It's a hungry printer. This thing is a hungry printer. Also, something I'll probably add to it in the future is a booster. A booster essentially acts like an extruder that pulls filament off the spool and feeds it to the tool head and lets the tool head take over there. That way the tool head extruder is not having to pull the filament from the spool, which when you have something like a 5 kilogram spool will come in really handy. So putting a booster on this, the Nevermore system, it does come with like a side pack Nevermore system to filter the air in the printer chamber. I'm probably not going to be doing that. What I'll probably end up doing is something akin to the Voron Phoenix, where I'll put some holes in this panel under the bed and put some ducting so it sucks hot air from under the bed, and then I'll have it blow up through the sides here and hopefully get a convection current going. A big printer like this, once enclosed, should have no problem getting easily ABS temperatures, 60, 65 C in the chamber. Again, we have like 1600 watts of bed heating here. There's already 4 heaters, 5 if you count the hot end in this chamber. We probably don't need any more. We just need to get the air moving around. So I'll probably do that in the future. And as you can see, I don't have panels on this printer for 2 reasons. One, the way the panels are designed to mount is inside the frame itself. This is a 40/40 frame. The gantry sits on the innermost 20/20 portion of that 40/40. So there's quite a bit of room around your gantry within the frame still. And these panels are designed to sit within that. But I'm not a fan of that. For example, at the back here, if you follow the manual, it has you run all your wires through the channel in the extrusion and put a nice little cover on it. But then at the end, it tells you to install brackets into that channel to mount your panels, which means you got to take the wires out. And I don't want to do that. I don't want to do it. I like the clean look. Also, if I mount panels on the outside, it bumps the panels out ever so slightly more. So that means I can put a little bit more insulation on the inside. I want to insulate this because it's going to be in my garage. In my garage here in the summer, it gets to 30 Celsius, but in the winter, it gets down to freezing. So I'm going to want to insulate this quite a bit, especially a large print volume like this, printing large prints. You're going to want it nice and toasty in the winter. So I'm going to look into sourcing some exterior panels for this that I can just bolt onto the side. Maybe I could find somebody who does ACM panels locally, so I could just get them cut to size with just some M5 holes, and I'll just bolt them right to the side with some foam insulation just to seal the gaps. So that's something I'm probably going to do. Also, I'm probably going to install more lighting in here. It does come with lighting strips to light up the printer. In fact, there's supposed to be LEDs underneath this X extrusion here, and I did install them. Unfortunately, I wired them up backwards, and they don't work because I wired them up backwards. And you can't take that extrusion, you can't take the LEDs out of the extrusion unless you completely disassemble the whole XY. You have to drop the whole X axis. So, yeah, we're not doing that. Again, I've already upgraded the tool head, the Rapido, to an ultra high flow. I may go to another hot end in the future down the line. For bed probing, it does come with a cartographer, so you can do those really fast, big bed meshes, and then you can also use touch for your nozzle offset. I've had pretty good first layers on this machine so far once I got everything set up. When it comes to leveling your bed, there are 4 separate beds here to level, and you do need to level them because there are 4 independent beds. The easiest way I found to do it was simply tighten the beds all the way down. So you just collapse the spring all the way down and you're sitting on these hardened mounts essentially. And then put your spring steel on, do a big bed mesh, look at the bed mesh, see what's low, and then just take the spring steel off, raise those screws up, let it rise up, and essentially just kind of let it undo screws until you get flat. I got this whole bed within 0.3 millimeters. 0.3 millimeters over 600 millimeters is as scientifically termed as possible. Diddly squat. I don't care about that. I'm good. The prints I've been printing, I've had no issues with first layer, so we're good to go there. So I think that's enough yapping about the printer itself. Let's go over to the workbench itself and take a look at some prints that we've printed on this printer, Printingly. So obviously I printed some calibration cubes and whatnot, but nobody cares about that on a big printer. You want to see big prints, so let's take a look at them. So fun fact, with a printer this big, if you angle a benchy correctly, you can print a benchy that's about 1,150% scaled up, and it's about 5 kilograms of plastic. I haven't gone that big yet, but this benchy here, I think it's either 600 or 650% scaled, and as you can see, it's pretty big. This is about as big of a benchy as you can print with the 0.4 nozzle with the default settings and still use less than 1 kilogram of filament. A printer this big, that 1 kilogram spool size is going to haunt you quite often. For example here, this right here is an engine block. So this engine block here, I think this is the Prusa demo engine block, V6 engine block. I printed this with the 0.8 nozzle, and I was using a partial spool of PLA filament. I had about 800 grams to work with, and I had to fiddle with slicer settings to get this down under 800 grams so that I only used up that 1 spool of filament. Now, obviously you can pause prints, swap out spools, you can use filament rollover. If you have a feature like that on a printer, you can rely on the end stop to just pause the print when it runs out. There's a lot of ways that you can use more than 1 kilogram or change the spool halfway through. But I tried to avoid that during the initial testing. So with this is 1 wall, 3 top, 3 bottom, and like 3% infill. And it just came under. I had a little bit left on the spool. So the problem you're gonna run into is you either print stuff really heavy, when you're printing big and use a lot of filament, or you try and tweak those settings to be as optimized as possible, and then you run into downsides such as, well, your top layers don't look too good because you really could have used that fourth top layer to smooth it out and fill in those gaps, or your bridging ain't the greatest there because, again, you don't have enough layers there. You don't have enough meat to get those curved surfaces, those angled surfaces to really come in clean, because you're essentially laying plastic on air. So that is something you're really gonna have to pay attention to. Find slicer settings that work, and in a lot of the cases, you're just gonna have to deal with the filament use penalty to get those prints being really good. But when they do come out good, they do come out good. Again, this is a 200% scaled Moon City print. You've probably seen this print a million times. Again, this is with the 0.8 nozzle. And one thing I noticed with the 0.8 nozzle that came with this kit, it is a CHT nozzle, so you do get a little bit higher flow, but I did notice it was a little bit stringier than a normal 0.8 nozzle that I had installed in it. So it was a little bit stringier. In fact, you could see that the most here on this stool. This is also around the point where the PETG parts were failing. So the extruder was getting a little sloppy. So as you can see, this stool is a little on the fuzzy wuzzy side. And in fact, by the end of the print, the extruder actually just kind of gave up. It missed the last like inch of the print or so. So it just stopped extruding. The extruder failed. After this print is when I replaced the tool head parts with PPS. But for those wondering, this is less than a kilogram of filament. It is a stool. I can stand on it. It does support my weight. Furniture. Another use case of a large printer. Print some furniture. Why go to IKEA? And next up, we have this Deadpool print here. This is a 200% scale Deadpool from Eastman. And this was printed in, I think, Buddy 3D PLA. It's red PLA. I've been using a lot of different filaments from a lot of different manufacturers to test this because I don't have a lot of PLA on hand, so I've just been going through my stock. Some of this is old, which probably explains some of the stringiness on a lot of these prints because it might be a little on the wet side. But also a thing that could explain the stringiness is the fact that I'm basically making up the slicer profile as I go. This printer only shipped with a single 0.4 millimeter slicer profile. So moving up to a 0.8 with higher flow rates, I'm essentially tuning it as I go, and it's getting better as I print more. The printer is printing better, especially now that I've replaced a lot of the PETG parts, which could explain some of the stringiness on some other prints. But yeah, this is Deadpool. As you can see, we do have some overhangs here. This was printed without supports. So we do have some pretty sharp overhangs here that came out pretty clean there, especially on his chinny chin chin. So not too bad of a print there. I also have this really big vase mode print here. This was, again, printed in PLA. This was with the original 0.4 nozzle with the original stock hot end. I over extruded this 200%. And there's really, I don't know any cracks in this. This actually came out, I've been using it as a garbage apparently. But this came out really solid. I wouldn't say it's watertight, but with a big fat nozzle and printing PETG, you probably could do some pretty interesting watertight vase mode prints. This one came out really cool. Now, I do have the Voronoi female figure print here. This was just a retraction hell test print. It was either this or the Eiffel Tower, and I didn't have a nice filament to print the Eiffel Tower in, so I printed this instead. But it's still stringy, so again, still tweaking settings, but this came out really good. When you have a big printer, you're gonna be able to print stuff that every household needs. Like this giant fortress of Barad-dûr from Lord of the Rings. This was a single piece print, a little bit of support up top here with the eye. Again, this was with a 0.8 nozzle. And fun fact, this is 1.7 kilograms of Prusament Galaxy Black PLA. And this whole print took less than a day. This is a 0.8 nozzle, 0.4 layer heights, 2 walls, I believe 5 or 10% infill. And yeah, this print took less than a day. In fact, every print you've seen on the table today was less than a day. This printer sucks down filament when you get it with the right hot end and the right nozzle size. So yeah, this, if you need your own Dark Fortress of Barad-dûr, there you go. So I've been having a lot of fun with this printer so far. I've been printing a lot of big things. Once I get it a little bit more tuned up and I'm a little bit happier with the settings, I'm going to move over to making sure it works with PETG. I do want to upgrade it to a hardened high flow nozzle so I can print CF PETG on it, because when it comes to some of the cosplay parts that I have in my backlog of things to print, having a massive print volume like that will definitely come in handy with some of those larger parts. You're not going to have to split them up into multiple different parts, but not every print is a success. And I could show you that here with this Stormtrooper helmet, because of course you can't test a large 3D printer without printing a helmet on it. That's the rule. And believe me, when you're printing a Stormtrooper helmet on a printer that big, it makes this helmet look absolutely tiny on that print volume. But anyways, long story short, as you can see here, we have 2 different colors, and it would have been really nice if this was a nice blended print, but no, this top here is glued to the rest of the print, because what happened was the print ran out of filament at like 3 in the morning. I expected that to happen. I figured I would just wake up, swap in a new spool and hit resume and move on with my life. But unfortunately, the way the macros were set up in the Venture XL, I guess there's a timeout. There's an idle timeout where if the print is paused for a certain amount of time, it just turns the heaters off, turns the motors off, and it just sits there. So after I got the new filament installed and I hit resume print, it wasn't home anymore. And the beds were cool. So I could have heated the beds back up and hoped the print still was sticking to the bed. Also, I could have rehomed the XY and then manually touched off the Z and told it where it was and resumed the print from there, because the print was still paused. The print was still paused. I just had to tell the machine where it was at. But that never works right. That never works right. And since I knew where it was when it failed, essentially I just went in the slicer, sliced the top of the helmet off, and then I just reprinted that separately after properly rehoming the machine. So big prints take time. You could speed up that time by using a big nozzle and a high flow hot end and get prints like this in under a day, but you're still dealing with a lot of plastic and a lot of waste, unfortunately, because not every print will work. This one started warping off the bed midway through, and this was 2 hours into the print job. This is 250 grams of plastic. That's garbage. Big printers, they use a lot of plastic, and if you're not careful and you don't have your settings right and you don't watch it, and for example, I don't have a UPS on it yet. I need to put a UPS on it, because the last thing I want is 3 kilograms into a 2-day print, the power flicker, because it's running Clipper. It doesn't have any ability to resume once the power resumes. So yeah, you need to pay attention to that. Pay attention to those downsides when you're dealing with a printer this large. But when everything is working and is printing well, it's bench-tastic. Okay, so we're back to the other side of the garage here. And by the way, if you're wondering why we're filming on this side of the garage, because this is the only place in my house I can have this printer. We had to build it over here, because if I had built it on the other side of the garage, I literally couldn't get over here. There's not a big enough gap between my shelving unit where my printers are and my fridge to get it over here. It's too big to fit through any doorways inside my house. So one of those things to keep in mind when building a big printer is where you're gonna put it. At least here, I can go out my garage door if I need to get it outside. I think my neighbor's cutting the grass right now, by the way. Anyways, so yeah, so big printer needs big room. As you can see, we have this printer elevated as well. Originally, this kit does come with some casters, so you can put the printer on the ground and move it around. I gone ahead and built a wooden frame here at about 50 bucks in 2x4s and screws from the local Rona. And then I put those casters on the bottom of the frame that I have the printer sitting on. So I can move the printer around. It's not locked in right now. So I can wheel it around, move it around, and then I can lock it in place when I am printing so it's nice and stable. So that is one of the little modifications I did. If you are interested in these TPU Fysetcs here, I'll have them linked in the video description as well. So what are my initial thoughts on the Fysetc Venture XL? If you know what you're doing and you need a quote unquote big dumb printer, it's not a bad option. It's pretty price competitive for a 600 millimeter size printer of this type, where you can enclose it. It can print materials up to ABS, ASA, nylons, polycarbonates, etc. It is I call it a big dumb printer because it doesn't have off the shelf something like IDEX or filament rollover. Essentially, it's just a really big normal printer. I could see some people looking for a more turnkey solution, not wanting to go with a printer like this. This is a kit. You do have to fully build it yourself. The only thing that comes pre-assembled is essentially some of the wiring in the electronics box. So if you are looking for a more turnkey solution, something like an Orange Storm Giga would be your option there. Although I don't have any firsthand impressions of the Orange Storm Giga, I have spoken to many others, and it's a kind of hit and miss when it comes to that printer. I know Luke from Luke's Lab really likes that printer because he sells the Blue Storm Giga upgrade kit, which is a kit to make your Orange Storm Giga a little bit betterer. So there's that. And it does have the advantage of the fixed bed. When you're printing large things on a bed flinger, that large thing is also moving around. It's changing the harmonics of the printer, how it behaves. You have the risk of, tall prints, swaying back and forth. With this, your print bed is fixed. Your print isn't moving. You have a lower center of gravity. It is more stable. You do have that advantage there, especially when you're printing 5-kilogram parts, for example. So again, like all things 3D printer, you need to look at your use case, your needs, your wants, your desires, and make the choice if this is the printer for you. If you are interested in it, I do have a link for it down in the video description below. I will continue working on this printer. I will continue using it. Maybe I'll do a follow-up video in the future. I do need to get it enclosed. I do need to start printing some ABS on it because I have a lot more ABS in stock than PLA. And considering, again, this thing will eat a kilogram of spool in 10 to 12 hours, I've actually gone through a lot of my PLA in the past couple weeks. So yeah, that is my initial impressions on the Venture XL. If you want to know more or have any more questions, ask them in the comments below. While you're down there, don't forget to like the smash button, subscribe to the channel if you're not subscribed, ring the bell, and make sure you don't miss out when we do our live streams. We live stream 3 days a week on this channel, so make sure you're subscribed so you don't miss out on those. And if you want to help support the channel, the content I create, and the things I do, consider becoming a channel member, Patreon supporter, or just check out some of the affiliate links in the video descriptions. Don't cost you anything extra, go a long way in supporting the channel. And some of them, like the Gamer Subs, the 3D Gloop, and the Vision Miner, you can save a little discount, use code Canuck. I'm Taylor Canuck Creator. I hope you enjoyed this video, and I will see you in the future. Cheers.